Greetings. Welcome to our 41st episode of the FGI podcast. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign. On today's episode, we are going to focus on our July 12th, 2022 webinar titled Live Panel Discussion on Expected Longevity and Applications of Exposed and Unexposed Geomembranes. I'd like to quickly reintroduce our distinguished panelists. Our first panelist in alphabetical order is Doug Hiltz. Doug is a registered professional civil and structural engineer in multiple states. He is founder, owner, and principal of Hiltz Consulting Group, located in Southern California, and he has over 30 years experience throughout the U.S. and internationally working on floating covers, reservoir liner systems, and other challenging geosynthetics application. So Doug, thanks for joining us. Our next panelist is Prabeen Joshi. Prabeen is an engineering business manager at Layfield Group in Vancouver, Canada. He has over 17 years of consulting and academic experience gathered in 5 continents. His graduate research at Queen's University evaluated the performance of geomembranes and GCLs in solid waste landfills and mine tailing storage facilities. Prabeen, thanks for joining us again today. And our final panelist is Adam Maskell. Adam is the global product manager for geomembranes at Solmax and has over 20 years of experience in the geoengineering industry. Adam has a bachelor's of science degree in mechanical engineering from Cal State Sacramento. Adam, thanks so much for joining us today. Okay, we had many questions during the live presentation and the follow-up. A total of almost 50. We've pared those down based on some of the ones that were answered during the webinar and that were very close to each other. And that leaves us with about 20 questions to answer today. So here we go. First question, what happens when you have an area that turns into a waterbed under the geomembrane cover? So that could be 2 options. It could actually be a floating cover over a reservoir, and so it is actually like a waterbed, or it could be a subgrade that's very soft. So I'm going to turn this over to Doug Hiltz to try to respond to that question.
Thank you, Tim. Well, obviously, if you had a floating cover, when they say geomembrane cover, if it's a floating cover, having water underneath the floating cover is acceptable, and in fact, that's what it's intended to do. No real issues. You'd want to look at your cover tension as a design parameter, but really no issues of concern there. If we're talking about a liner application, water underneath a liner application where you would have an upward force trying to buoy the liner geomembrane material upward, there could be some concerns with that depending on what that uplift force is. Inducing tension in the material and possibly inducing some long-term strain. So it wouldn't be a major consideration if it was a minor amount of water, but depending on what those uplift forces are and the strains in the material and the longevity of those forces could bring some areas of concern.
Great, Doug. Thank you. Prabeen, the next question is for you. In your experience, how effective are base liner geomembranes in low-level waste, radioactive waste disposal facility, especially in terms of chemical interaction and physical damage by waste settlement and placement?
Thank you, Tim, and thanks for having me back for the podcast. So low-level radioactive waste can be different, so it would be evaluated on a case-by-case basis. But and also the regulators require the geomembrane to last, depending on the jurisdictions, centuries. Could be 200, 500, even 1,000 years or over that. And I've seen HDPE geomembranes used for low-level radioactive waste disposal facilities, mostly from the remediation angle. And there are some research works that I'm familiar with as well, and that shows the geomembranes chemically do perform very well under those exposed conditions. In fact, the leachate that comes from the low-level radioactive waste can be less severe compared to a municipal solid waste leachate. And in terms of construction and physical damages, all the other precautions and construction procedures needs to be taken so that construction damage is virtually eliminated in hazardous waste, especially. And I also recommend going and looking at the FGI webinar that was done on a similar topic last year.
Great, Praveen. Yeah, thanks. And that's Rudy Bonaparte's webinar on the siting and construction of a low-level radioactive waste facility in Ohio. So thanks. Praveen, you've got the next one too. Is it common to see access roads constructed on exposed geomembranes for access? If not, how would an MSW landfill go about getting heavier equipment on a landfill after closure?
Yes, in some instances you cannot avoid driving on the geomembrane, but in no condition you should drive directly on top of the geomembrane without adequate cover. And there are different cover thickness requirement depending on what you're driving. So typically, if you're looking at a low ground pressure equipment, which is 35 kPa or 5 psi or less, if possible, and in those cases, you would need at least a 30 centimeter or a foot minimum fill. And if the ground pressure of the equipment is higher, the thickness will be more, and there will be requirements in terms of turning and not and driving straight. And also, if it's on the slope, the geometry of the slope will have to be considered as well. And in some cases, it's inevitable to drive on the liner.
Right. Okay, next question. Adam, this one's for you. Covering a geomembrane plays an integral part in achieving intimate contact between the geomembrane and the underlying compacted soil liner or layer, could be a subgrade. How is intimate contact achieved with exposed geomembranes?
Yeah, that's a great question. Exposed geomembranes are not inherently ballasted when they are exposed, and so the trick is getting the ballast to come out of those when the membrane is at its minimum temperature. That tends to resolve itself quite a bit if you're talking about a liquid containment, if it's not a hot liquid anyway. The liquid containment is oftentimes on the cool end of the spectrum, and you're covering at the water line, covering and submerging areas of the liner that are contracted because of the relatively cool liquid. There are times when there's nothing that can be done, and there are some wrinkles that are inevitable. And if that's the case, then it's important to accommodate that into leakage calculations and appropriate action leakage rates and that type of thing. I know Queen's University has done quite a bit on kind of the complex geometry and leakage through wrinkles that do end up staying in membranes. So that would be a good resource to look at there.
Great, thanks, Adam. Next two questions also for you. Does adding more UV stabilizers, say up to 6%, increase exposed life, and is that advisable?
I can speak to the polyethylene end of things, and I can say wholeheartedly no. The thing to consider when adding UV stabilizers is, one, the effectiveness of the stabilizers and the quantity that there is to oxidize or consume. The other is kind of a solubility type of consideration, and there's generally a limit on how much stabilizer a given material can hold on to. And so oftentimes, one of the things that we consider during formulations is adding an appropriate amount of stabilizers so that they stay in the material. So adding more UV stabilizers may make numbers look good up front, but if you look at longer aging type tests, the higher concentrations of stabilizers, when you try that, usually will come out of the product and be oxidized on the surface. They just don't stay in the material long term. So there's not a whole lot of benefit long term to doing that. Instead, it's usually more effective to use better UV stabilizers rather than just more UV stabilizers.
Yeah, good point. Okay, one more for you, Adam. What kind of temporary covers are acceptable for exposed geomembranes at landfills?
We've done quite a few with 40 mil linear low geomembranes, oftentimes with an HDPE skin if they're going to stay exposed for a handful of years. But if you look at the half-lives of any of the common geomembrane materials, we're talking half-lives of decades. So really any of the common membrane materials can work. Oftentimes for temporary covers, we're looking at a cost being the primary driver. Don't want to put a very expensive membrane in just to tear it out and replace it. One other approach is to do something that can become part of a final cover if that's an option. So we're talking about the leading edge of a landfill cell, for example, where they're advancing an exposed membrane out. And if that's the case, you may look at using something that will have enough of its service life left after the exposed period to just become a part of the permanent solution.
Okay, great, thank you. Doug, next one's for you. This listener is interested in hearing about effective methods for preventing wind uplift when capping long slopes.
Well, I think that's kind of a two-pronged question. You have exposed and covered slopes. Obviously, if you're covering a slope, you'd have possible materials would be soil, concrete, maybe a geo-web backfilled with draining rock or gravel. So if you're ballasting it with cover, that would be one way. If it's an exposed geomembrane, there's a variety of different ways and combinations that could be utilized. Anchor trenches, obviously, you would typically have an anchor trench at the top of slope. You may have intermittent anchor trenches at benches or running down the slopes. You could use ballast tubes would be another option. Earth anchors would be another option. So it would be really a function of where the project is located, what the design level wind speeds are, where it is within the site, if it's on the slopes, at the crest, or out onto the floor. That's going to vary your wind uplift forces. And it depends on the material and what strength the material is and how much strength is available, and that's going to determine your ballast size and your ballast spacing.
Yep. Okay, next question, Adam. Would you use both standard and high pressure OIT testing, or choose one based on initial or specified values?
Well, it depends is the easy answer. I think it's important to understand a little bit about how geomembranes are stabilized and protected from oxidation. Generally speaking, now there are higher temperature antioxidants that are active at higher temperatures and lower temperatures. Specifically, the hindered-amine light stabilizer type antioxidants are very, very good at protecting from UV exposure. But at the temperature the test runs for an OIT test, they'll just boil out of the material and be gone. So an OIT test does not reflect, a standard OIT test doesn't reflect how well some of those more recent antioxidants will perform. The standard OIT test, though, is important because it's an indicator that there's enough high temperature antioxidants to get the material to survive processing and welding and things like that. So there may be times when you'd want to specify both. To get the kind of minimum industry standard expected lifespan, oftentimes either one is an appropriate way to go. There are cases to be made when for testing both. I think it is probably excessive to test for standard concentrations and standard aging performance of both I don't think that's necessary. I think that you can have a combination of the two of those, where you want some of, say, for example, some standard OIT, but your major performance indicator would be high pressure OIT, and you're kind of double checking to make sure that there's some capacity for standard OIT. But if you look at industry standard GM13, GM17 type materials, meeting both of those, especially the oven aging requirements, is probably a bit excessive.
Okay. Praveen, next, in leachate dam applications, where the dams are 90% full, essentially up to the freeboard level, would it be advisable to have the exposed area protected with turf reinforcement mat or maybe a sacrificial geotextile to ensure that the two areas exposed and covered with leachate don't deteriorate at different rates?
That's an interesting question. You could, but in this case, you're assuming that the submerged geomembrane is deteriorating slower than the exposed one. So you want to protect the exposed one. And also the attention should be given to the performance of the TRM, or the sacrificial material that you want to place on the exposed one. How do they perform when they come in potential contact with the leachate due to leachate level fluctuation? I know it's already 90%, but there could be wave actions that would bring it into the contact. And also attention should be taken because TRMs are not really designed for such applications. And there are lots of different kind of TRMs. Another thing that I would recommend is looking into covering the pond with a floating cover, such that the treatment volume can be reduced. I'm assuming this is an area where precipitation will add into the leachate volume, and if the cover is placed, the original issue of exposed liner will also be eliminated.
Right, good point. And TRM, of course, is turf reinforcement mat. Okay, number 10, let's see if we can get through all of the webinar questions, and then we'll do a podcast on the after webinar questions. So number 10, Praveen, this is you again. Landfill geomembranes are intended to keep liquids out and gases in. Penetrations through exposed geomembranes, for example, gas extraction wells, seem to be a weak point. Can you discuss current best thinking on penetration boots?
Sure, I'll keep this short. A well-designed and well-constructed and monitored, monitoring is quite important, they can perform as intended for a very long time. But we should also remember that this area or the boots area is not the one that has progressed as much as compared to other areas of the geomembrane construction. So for that reason, operation and maintenance procedure that has been adopted for these facilities should also focus on boots and from an inspection and a preventive maintenance point of view.
Great. Next question. Doug, this is for you. What design methods or references are typically used for the design of exposed geomembrane covers on slopes?
Thank you, Tim. There are several references in the form of articles or books written by J.P. Giroux, Kerner, and others that would be valuable for a designer to consider. The design should often consider wind uplift, the in-service tension of the material strength. You'd want to look at the soil geomembrane friction. You'd also want to consider the exposure of the geomembrane to both UV and weathering. And it's also important to, in selecting your material and designing your material, is what are the pond contents? What's going to be in direct contact with that geomembrane material, and are they compatible with one another?
Great. Doug, next one's for you too. Are vertical anchor trenches, i.e. running up and down the slopes, more commonly used in exposed geomembrane covers? What are the pros and cons of vertical versus horizontal anchor trenches for exposed geomembrane covers?
Quick answer to that, it depends. It really depends upon the facility geometry. how steep are your side slopes, how long are your side slopes, what are the wind uplift forces. I've seen both used. Obviously, you have a trench running around the perimeter, but if you have intermediate benches, you could use intermediate trenches along the intermediate bench and not have any trenches running up and down slope. If you have very long runs on a relatively mild slope, you may consider running ballast trenches up and down the slope. So I think a lot of it also depends upon the how steep the slopes are and how long the runs are. So I've seen both used. I've used both. It kind of has to be on a case-by-case basis.
Great, thanks, Doug. Two more of the live questions. Adam, next one's for you. An advantage of exposed geomembranes is that damage is easy to spot. Is there technology existing or in development that can detect damage in a covered geomembrane?
Yeah, there sure is. If you look at the ASTM test methods for electrical liner integrity surveys, the dipole test can survey through water or soil with some moisture in it. So there's a test method for that. And for more information on that, I believe that some of that was covered in the action leakage rate podcast that FGI put on a while back. But yeah, the dipole test methods are the ones that operate through cover. And when looking at those, site preparation and design is particularly important. You do need to make sure that you have a conductor in intimate contact with the backside of the membrane in order to make those test methods work. So it may be difficult after the fact, especially if you have two geomembranes in a double line system where those are being, one is acting as an insulator that may insulate the top membrane from ground below. You also have to look at geomembrane composition and make sure that the membrane itself is an insulator rather than a conductor. You need an insulated layer in there, and that's really important, especially with the dipole survey. That the sensitivity is not quite as high with the dipole test method as it is with an exposed membrane cover. And then oftentimes during installation, you may do both. So you get a baseline with an exposed membrane cover to rule out any even smaller holes. And then when you're detecting damage in a covered membrane later on, if it was ruled out, then you know that you're just looking for bigger holes, and that can kind of simplify the testing. So, and then on very deep covered membranes, there's some geophysical test methods that can be used. I don't know that there are specific test methods for those, but they are out there, and you could look for hydrogeophysical test methods, and that's going through materials that are, say, more than about a meter thick. You can, again, the farther away you get from the membrane, the less sensitivity there is, but there are some things out there that can be done.
Okay, great, Adam, thank you. Our last question from the live portion, or during the live webinar, is number 14. That's for Praveen, and then we'll record a second podcast for the questions submitted after the live presentation. Praveen, the criteria for closure is, quote, forever, 1,000 years or 10,000 years. Then is it possible to trust a product that will not last forever, even if it is unexposed? Oh, a difficult question.
It is, yeah. So in reference to the product, I think the question is referring to a geomembrane product. And geomembrane are synthetic materials. The nature doesn't know how to break it down, and we're sort of using that in our advantage. And to be honest, we are very limited by options here. Trust is one aspect, and an educated engineering evaluation is another aspect. So based on what we have at the moment, I believe geomembranes are one of the few economical and engineered product that can be used in such applications. And if the design is done properly, as I said, it's a synthetic material, nature doesn't know how to break it down. So if all the temperature, UV, and all the others that we also discussed during the live discussion are taken into account properly, then it would, or the prediction is that it would last that long. And yeah, again, as I said, we're limited by options here.
Okay, great. Thanks, Praveen. That finishes our questions that were received during the webinar. I'm going to stop the recording and we will create another recording for the questions submitted after the live presentation. Greetings. Now I'd like to focus on the questions we received after the live presentation by the panelists on exposed and unexposed geomembrane applications. So we have a number of questions here that we've combined into 5 overall questions. So our first post-webinar question is for Adam. Adam, what is your opinion on using exposed geomembranes for leachate lagoons or any water in cold climate where a significant thickness of ice can form during winter? I'm against it, but some consulting firms will use it with the client approval to save cost. Is a leachate storage lagoon with variation of water level, a full cover of ice developed, could that induce important stresses on the geomembrane system at the water line, especially as the water goes up and down on a 3-to-1 side slope?
Yeah, and actually, I had a chance to go out to a site that has it's not a municipal leachate, but an industrial pond with 3-to-1 side slopes up in the mountains in the Rockies, and they do get a sheet of ice that forms every year, and they have procedures in place for dealing with that. I think that the most important thing to clarify is that you probably don't want to use a completely exposed membrane if it is a really high risk operation, because a sheet of ice that forms, and especially if there's wind and the ice gets blown around, that can create damage, can and does create damage. There's no question about it. You may be able to mitigate that damage with using a double line system. But armoring of some sort is most certainly warranted, in my opinion, anyway. But if you are in a lower risk situation where you have it's not the end of the world for some leakage to leave the system, I think the important thing is to make sure that the water level doesn't go back up after that first freeze. And also inspections of some sort, whether that be a visual inspection. The site that's been really successful has a contrasting white layer over a black surface, but any 2-color system would be appropriate for visually detecting damage. And they just go and inspect and repair with an electrical method once a year. But again, that's a lower risk. If you're looking at a leachate lagoon from a landfill, that's probably not going to be acceptable.
Okay, so Adam, just a quick follow-up. Would a reinforced geomembrane be able to handle the stresses induced by the ice, even if there's wind?
Probably not entirely.
Yeah.
What we're talking about is sharp ice being blown across the surface of a pond, and it's like a knife. It'll cut through anything that can be cut. So in that case, I don't think that reinforcement is any match for it either. As much as I'd like there to be an exposed membrane option, I really think we need to be careful in that setting.
Yeah. Okay, great. Thanks. Praveen, next one's for you. In the coal mining business, there's a plan to use a geomembrane for a refuse area. How steep can the geomembrane be and remain stable? So this is like coal combustion residual disposal facilities.
Right. Sorry. In general, liners can be installed near vertical as well, with adequate support. But the challenges will be there with difficult installation and safety procedures and all that. But if you're considering a slope, it will depend on several factors, such like the geomembrane itself, cover material, and if you're talking about CCR, that's usually a very fine material. Then you're also looking at pore water pressures, or the interface friction properties because of the presence of moisture. And what type of loading are we looking at? Static and dynamic, and length of the slope, and there are other factors as well. But in most cases, as a guide, I would say 3-to-1 or flatter slopes are safer. But I would nevertheless recommend that a site-specific evaluation is done for the material, the CCR in question, as well as the geomembrane in consideration.
Okay. Prabeen, next question's for you also. How are geomembranes made temperature resistant?
Okay, so geomembranes are comprised of many different materials. So base polymer, carbon black, and then stabilizers and additives are placed in it. All of them can be altered, or there are different varieties of those. So additives play a huge role in terms of making a geomembrane temperature resistance. And conventional geomembrane, you can add different types of additives, and that would resist different temperature levels. But there has been advancement in the polymer technology as well, and the geomembrane industry is slowly adapting to a polymer that came from a piping industry, for example, going from a unimodal type of polymer to a bimodal that would change the amount of molecules, or long chain, short chain molecules, or the molecular weight, different molecular weights. And these base polymers are also called PERT, or polyethylene for raised temperature, and those can resist much higher temperature. So the consequence of increasing the temperature is the retention of the antioxidants. So if you go with a standard geomembrane and raise the temperature, then the antioxidants will leach out faster, versus the geomembranes that are specifically designed for higher temperatures, they can retain those antioxidants for a longer period of time. So that's sort of like a molecular adaptation, or adaptation in a molecular level. That's how the industry is shifting towards creating more resistant geomembranes for higher temperature.
Great, thank you. Adam, next question's for you. For the landfill application, if the operator is wanting to leave the geomembrane exposed for a period of 1 to 4 years prior to placing the drainage layer or a select waste layer, would a thin sacrificial geotextile be of benefit?
Yeah, and looking at that, it would be a benefit, but the question is, does the cost weigh up to what the benefit is that's provided? If you look at a non-woven textile, there's so much surface area in those that they really don't tend to last, and those would fall apart and make a mess if you were to leave them exposed for 4 years. So if you're doing that, you're looking at using some sort of a woven textile, woven, possibly like a monofilament woven, and the costs are pretty significant for those. So from what I've seen, there can be benefits from if mechanical protection is needed. If we're talking about UV exposure, it's generally more cost effective to use a better geomembrane that has stabilization and formulation that's intended to extend the UV surface life and protect it that way, unless you're talking about mechanical protection. And then woven textile is oftentimes a good way to go. And there's really no substitute to having soil cover over the surface of those, if at all possible.
Yep. Okay, last question from the post-webinar question bank. In South Africa, a new practice is to cover HDPE geomembranes of pollution-controlled dams with a geocell filled with cement stabilized material or low-strength concrete. And the reasons are UV protection, protection from higher temperatures, vandalism, etc. The application is obviously very labor intensive and has some challenges. Can the panel, Prabeen, provide some advice on other products to cover the HDPE geomembranes that are not as labor intensive as these geocells?
That's an interesting challenge, and some of the comments that Adam just gave in the previous question do apply for reason number 1 and 2, which is UV protection and restriction or higher temperature for the exposure area. But the third concern, theft and vandalism, is pretty interesting one. And using a geocell, it's a very versatile application. It's a very versatile material. The only thing that I can add to this or comment is the compaction. You may not necessarily need the compaction that you would otherwise need for soil enforcement application. So you could use a very lightweight fill within those cellular or geocells, and that could be one way to achieve what you're trying to achieve. Or we talked about the geotextiles and TRMs, could be another way to look at it, or soil cover without a geocell if the slopes could be flattened further.
Okay, great. And I'm assuming here in South Africa that land is tight, and so they won't be able to flatten a slope, but so I think it's going to be one of those other applications.
Right.
Yeah. Okay. Great panelists. That is all of the post-webinar questions. So thanks to Doug, Prabeen, and Adam for joining us again. And that is all the time we have today. If you have additional questions or would like additional information, please send your questions to the FGI at fabricatedgeomembrane@gmail.com. You can download the webinar slides, and the email addresses and contact information for the panelists are at the end of their presentation, so you can also contact them directly. So Doug, Prabeen, and Adam, thanks so much for joining us again.
Thank you, Tim.
Yeah, thanks for the opportunity to participate.
Thank you, Tim. Appreciate it.
Great, everybody. Thanks.